Once training is complete, you will be automatically redirected to the Predictions tab. Let me first show you some of the metrics you will find on the metrics list. Besides the target metric, Neuton calculates additional metrics for each task type. For binary classification, for example, you can find the area under the curve, logarithmic loss, Gini coefficient and more. To the left from the metrics list you can find model quality diagram. It is a graphical representation of model quality in relation to metric indicator values that are scaled in the range from 0 to 1, where 1 is the ideal quality of the model, 0 is the minimum quality of the model. In addition, you can find the confusion matrix. Also known as an error matrix, this is a specific table layout that allows visualization of the performance of the algorithm. Each row of the matrix represents the samples in a predicted class. Each column represents the samples in an actual class. The matrix makes it easy to see if the system is confusing two classes. To read more about metrics, please refer to the support library. Now, I'd like to show you the model feature importance matrix. After the model has been trained, the platform displays a chart with the 10 most significant features. In other words, the 10 features that had the most impact on the model prediction of the target variable. In the features column you can see the names of the features. In the rank column you can see their importance on model prediction. And on the bar chart you can see the normalized importance value. You can select features to display, using the Add Features button. Using checkboxes, you can unselect irrelevant classes, to hide them. Let's return to the Prediction tab. If you want to use the Neuton model via the web interface without coding, click Enable Predictions. Let's wait a moment while prediction is being enabled. Excellent. Web predictions are available now. Let's look at how to use the web interface to make predictions without any coding. Click Start to begin. You should specify the dataset you will use to make the predictions. This dataset is a CSV file which must have the same structure as the training dataset, except there should be no target variable. For our purposes, I will use the trained model to predict the target variable values for the preloaded dataset Titanic. I drag and drop the test dataset with new data. The test dataset for this example can be downloaded from the Kaggle Titanic ML competition website. You'll probably notice that the interface is similar to that of training dataset selection. If the dataset used for predictions has a different structure than that required, you will receive an error message that the data is not valid. Click Start. Prediction may take a few minutes. You'll be notified by a pop-up window with a message when the prediction is complete. The prediction has been completed. You can click the Download button. A file with prediction results will be downloaded. Let's click the View button in the pop-up window. You can now see the predicted values in the first column. These values are predicted values for the target variable survived. And in the probability of 0 and probability of 1 columns, you can see additional information, the probability of a predicted value. After class probabilities you can see the model to data relevance indicator. This shows how trustworthy the predictions are. The model to data relevance indicator is determined by evaluating the statistical difference between the data used for training and the data used for predictions. If the data uploaded for predictions is significantly different from the training dataset, then the model to data relevance indicator may decrease. For prediction results relating to the regression task type, you will see the confidence interval and confidence probability. The confidence interval shows the possible prediction spread, for each predicted value, with calculated probability. Let's click the Model Interpreter button to activate this tool. It allows users to interactively change original feature values to see how the prediction results change. Features are ordered according to their rank in the feature importance matrix. The numeric features are represented as area charts. The feature values on the horizontal axis are ordered from minimum to maximum. For each numeric feature value, you can see the corresponding prediction value. You can also see the feature influence on the prediction result. A positive feature influence value means the predicted target value will increase when the feature value is increased. A negative feature influence value means the predicted target value will decrease if the feature value is increased. The categorical features are represented as bar charts. On the horizontal axis, you can select any feature value. For the classification task type, you can see the predicted class along with the probability. For all features, hovering over any feature value will show you the corresponding prediction details. Also, for any feature, if you left-click and move the pointer to the desired feature value, and release the left mouse button, the prediction result will be recalculated given the new feature input. You can click the Return button to return to the original feature value. Using the slider, you can specify the threshold value of the target variable, and Neuton will highlight the corresponding values of the original features for which the prediction result is above or below the threshold value. For the classification task input, the minimal probability of the predicted class is used as a threshold. This way you can quickly see which feature values you need as input to predict above the selected threshold. Let's close the Model Interpreter tool. You can see the historical model to data relevance indicator value. It is based on data from the model to data relevance indicator. This metric aggregates the statistical differences between the training data and all new data sent to the given model for prediction, over time. A significant decrease in the historical model to data relevance indicator's value typically means that you need to retrain your model on new data. Now you know with a high level of confidence which passengers survived the disaster and which, unfortunately, didn't. Congratulations! You have now learned the full Neuton AutoML workflow, from dataset uploading to prediction stage, and can easily solve any classification or regression task with Neuton. For more advanced users with skills in programming, stick around to learn how you can use a hosted model to augment your own application with AI capabilities, and how to use a trained model without Neuton. In this video, I will show you how to use a Neuton-hosted model with REST API. Say for example, you have developed your own application, which you would like to augment with Neuton AI capabilities, by sending prediction requests to the Neuton platform. On the Prediction tab, click Access Instructions when prediction is enabled. In the resulting pop-up window, you will find instructions on how to send a request for prediction of a single line or a whole file. You will also see possible return statuses, and get a request for prediction results. Further below in the same pop-up window, you will find code samples for different programming languages including Scala, C#, Java and Python. Let's consider an example for Python. First, to run Python scripts, you must have Python 3 installed on your computer. I will use Spider to edit and run Python scripts. Spider is an integrated development environment for Python. Let's go ahead and click Python to download a code example. Unpack the downloaded archive and open the Python sample.py in Spider. In the script you should specify two arguments for the send request function. The first argument is a URL in row number 6. Copy-paste the URL from the access instructions, which is equal to the URL address of the hosted model before the fourth slash, but not including it. The second parameter in row number 7 is the path to test the dataset, which I downloaded from Kaggle. I will specify the name of the file as test.csv. And copy-paste the file to the same folder, where my script is located. You can choose to specify a full path to the file, if you prefer. In samples we give for other programming languages, you should specify the same parameters, the URL to hosted model, and path to the test dataset. Now we can run the script. The script results will be saved to the folder where Python sample.py was run, and will have the same structure as you saw during prediction in the web interface. Over the next few minutes, I will walk you through how to use a trained model without Neuton. On the Prediction tab, click the Download button. Then select your operating system, for example, Windows. The archive will be downloaded. Unzip the archive, and open the folder. Because my Titanic prediction has a binary classification task type, I will run classification example.py, a script to predict on new data without Neuton. In case of regression task type, you should run regression example.py. For more information about archive structure, please refer to Neuton User Guide in the support library. Let's go ahead and open classification example.py in Spider. In classification example.py you should specify the path to the dataset, for which you wish to make the predictions. My test dataset is named test.csv. I will copy-paste the test dataset for which I will make the predictions, to the same folder where classification example.py is located. In my case, I will leave the file name test.csv unchanged, in classification example.py, but you can specify the full path to your file, if desired. Now I can run classification example.py. My output will be saved in an automatically created folder. The resulting file name is test with predictions.csv. The file structure is the same as seen previously in the web interface. You can see the predicted values for the target variable survived in the first column. And in the probability of 0 and probability of 1 columns, you can see the probability of the predicted values. Congratulations! You have now learned how you can use a hosted model to augment your own application with AI capabilities, and how to use a trained model without Neuton. In this video I will show you how to use Postman for prediction via REST API of the Neuton platform. Postman is a software for API development, testing and debugging. Before using Postman for predictions you must train your model and enable web prediction for your solution. You have two options for sending prediction requests in Postman. The first option is to send the formed data in JSON format. And the second option is to send the whole file for prediction. Let's review the 5 steps to predict on CSV file. I will use the Titanic test dataset from Kaggle for this example. Step 1. Copy the second URL from the access instructions for files. You will use this URL in the Postman request URL specification. Step 2. Open the Postman application, and on the New tab select Post Request Type. Then select Body. Click the Form Data Radio button. Type File in the key field. Check the box. Then navigate to the file with new data using the Select Files button in the Value field. Now, paste the URL from Step 1 in the Request URL and click the Send button. Step 3. Copy the returned UUID. Step 4. Open a new Postman tab. To view the data processing status returned by Neuton platform, paste the URL from Step 1 in Request URL. Replace the file with the status UUID at the end of URL. And click Send. Neuton should return with the status Success. Step 5. To get the prediction results, open a new tab in Postman. Paste the URL from Step 1. Replace file with the result UUID at the end of the request URL. And click Send. You will see the prediction results for the whole file. You can see the predicted values for the target variable survived in the first field. And in the probability of 0 and probability of 1 fields, you can see the probability of the predicted values.
Thank you for using Intelligent Agent.